Hey, so you were assigned question number 2 on the um, quiz review, and what that means is tomorrow in class you are going to get a very, very, very similar problem along with 3 other problems, and you're going to be in groups of 4. So you are getting an advantage of looking at this problem first, and you're going to be the expert on this problem, and then you'll have teammates who are experts on the other problems, and you'll work together to collaborate. I've always find that students learn best when they work with each other and can explain it to each other. The person who's explaining learns well, and the other students learn equally as well when they have that opportunity. So, you are tasked with question number 2, and here it is. By all means, you can look at the other YouTube videos for questions 1, 3, and 4, but this is your question. This is what you're responsible for in class tomorrow. So we have a 45-kilogram girl playing cops and robbers, so she's tied up between 3 trees. First tree is exactly north. North of the girl, and there's a tension of 34 newtons. So I'm just going to try to start drawing this scenario. Well, if she's tied up in terms of tree, she's not going to be hanging from a tree or getting pushed up by a tree. So this is one of those problems where it's the what's bird's eye view from above. So what that means is that Fg equals Fn from one of the problems from the worksheet that we did yesterday. And those don't matter. Those don't contribute anything to the acceleration. Those cancel out. We don't have to worry about them. So we're looking from above, and we have a couple forces to deal with. So say up is north, and it's a force of tension of 34 newtons. Second tree is 10 degrees north of east of the girl and exerts a tension of 56 newtons. So north of east would be here. That's 10 degrees and 56 newton tension force. There's that arrow. We have to determine where the third tree must be and at what tension it must have. So this is a little tricky. In order so that the girl is in equilibrium. That equilibrium term means that the overall net force equals 0. Vertical net force equals 0, horizontal net force equals 0. So it has to be canceled. And you can probably get a decent idea of where that force is. This one's going up, this one's going up and over to the right. So our third rope would have to act probably something like that. It's going to have to be somewhat big, and just making a guess. I don't really know, but we'll find out. So something along those lines is where I think we're going to find our third and final tension so that all net forces are 0. Well, the first thing we have to do is break this force into its parts. And to do that, we use sine and cosine, where this Fty is 56 times sine of 10 degrees, and this Ftx is 56 times cosine 10 degrees. Kind of looks like 5, 6s. 56 times sine of 10 degrees is 9.72 newtons. 56 cosine 10 degrees is 55.15 newtons. Alright, so our free body diagram resets. We're holding off on this force right now because we don't know anything about it. Our free body diagram resets to, you have a tension force. Let me draw this over here a little bit. Get rid of this. Just draw this a little lower so we have a little bit more space. So our tension force, just from the first tension, is 34 newtons. From the second force, we have an additional up force, an FTY, of 9.72 newtons. And then we have a rightward force, FTX, of 55.15 newtons. Alright, so to figure out what this force is, whatever that one is, we've got to do a couple things. First is, this force has to perfectly balance all of those three forces. So, we first have to figure out what these combinations of forces are. Well, 34 and 9.72 are in the same direction, so 34 plus 9.72 is 43.72. So we really have a 43.72 Newton force up, and then a 55.15 Newton force over. And this tension force down here, the one we're looking for, has to cancel that, has to balance it. So that means that if the net force is 0, F net Y has to be 0, and F net X has to be 0. Well, F net Y is total up minus total down. Our total up is 43.72, which means that our total down has to equal 43.72. So we need a piece of the down force. Let's start building this. We need a piece of this down force to cancel. It needs to be 43.72 newtons. And we need a piece of our, now we look at our horizontal, and we know that it has to be total right minus total left. And our right force, 55.15, if this equals 0, then our left force has to be 55.15. So we need a leftward force, which is going to be here, all the way there. But I'm not going to draw it here because I'm trying to figure out what this triangle is. On the free body diagram I would draw, if this is my free body diagram, I would draw these like that. But since I'm not working on an actual free body diagram, I want to draw tip to tail 55.15 newtons. So I have to balance this, and my tension force, this Ft right here, I just have to find using Pythagorean's theorem. The 43.72 has to cancel the upward force of this plus this. The 55.15 has to cancel the horizontal force of this 10-degree force. So 43.72 down to counteract the 43.72 up, 55.15 left to counteract the 55.15 to the right. Pythagorean theorem tells us that the third tension force, 43.72 squared plus 55.15 squared, square root, is going to be 70.38 newtons. So that's the magnitude. And we have to find the angle. To find the angle, you use the inverse tangent. Just run out of room here. Put it up here. Theta is inverse tangent of opposite. So this is the angle we're going to get. Opposite is 55.15 over adjacent 43.72, which is going to be inverse tan 55.15 over 43.72 at 51.59 degrees. And this one would be not south, but west of south. So there it is. There's your third and final tension force that we're trying to solve for. This force is what was required to hold that girl in place so that she doesn't move. Her net acceleration is 0 meters per second squared. You are responsible for this type of problem. The only thing that'll be different is different angle, different numbers, but it'll be the same thing. You'll have three forces. So hopefully You can take this and teach your classmates. Key parts were break the angle here into its two pieces. Use those two pieces to find the net force up, the net force over. We have to set other forces on this triangle to cancel those net forces up and net forces to the right that we found in the beginning. And then using those net forces, the thicker lines right here, we can put them together using Pythagorean theorem to get 70.38 newtons and use the inverse tangent function to find the angle, 51.59 degrees west of south. Good job!